Thanks for this opportunity. In this seminar, I'll talk about InSAR to study volcanoes of the East African Rift. And this project is also funded by the Italian Space Agency and a project called Space It Up. This is the East African plate boundary, and it has been created by the separation of three tectonic plates: Nubia, which is here on the left, and Somalia and Arabia. And the divergence between Nubia and Arabia is about 18 millimeters per year. And it generated the rift branches called of the Red Sea and the Gulf of Aden, while the extension between Nubia and Somalia is much less, 6 millimeters per year, and it created this main Ethiopian rift. The depressed area is where most of the volcanic processes occur, and these are focused along narrow rift segments, the red oval areas that you see here, and which are practically intensely fractured and faulted segments, but also punctuated by central volcanoes, these black outlines. And it's also a relatively young rift, where rifting started only 30 million years ago. And in this seminar, I am mainly going to talk about Ertale and the two last dike intrusion experienced in July and just a few days ago in November 2025. It's also very famous, the Ertale volcano, because it holds a permanent lava lake where you can see the figures here. So it's a famous site. And in this seminar, I'm going to show a lot of interferograms. So here I'm explaining a bit how it works. SAR satellites are continuously orbiting our planet and acquiring data. And what exactly do they measure every time they come over a given area at hypothetical time here called A? Well, they measure very precisely the distance between themselves and the ground by pointing at an angle. And they measure that very precisely by using the phase. And because they do this operation continuously, they will come back over the same area after some time and make again the same measurement, which is to very precisely measure the distance, which is also called range in lingo. And so by taking the difference between the data acquired at time B minus the one acquired at time A, we can have a very precise measure of the ground motion that occur between the two epochs. And the advantage of InSAR is that it doesn't just make this measurement on one point on the top of the volcano, as I show here, but for all pixels on the ground. And therefore, we can have an image, really, of all the ground motion that occurred. The drawback of the technique is instead that, as you can probably see, it doesn't really measure the vertical motion or the horizontal. It's a one-dimensional measurement, and it measures along its own geometry called the line of sight. And fortunately, also, we have more than one acquisition in different geometry, and I'll come back to that in a minute. Interferograms are this map of deformation, and commonly they show all the deformation that occur between the two epochs as cycles of colors, which we define fringe. So from, say, the distal area to count one full cycle of color, like in this example, from blue to yellow to pink, it will be one fringe. And one fringe is also half the wavelength of the satellite we're using. And because we mainly in Europe use European satellites, then half a wavelength or one fringe is 2.8 centimeter of motion, either away or towards the satellite in its own geometry. And we can clearly count all these cycles of color, so we don't have to be remaining with deformation expressed as series of fringes, but we can also have the complete continuous deformation field. And magma, lots of magma motion have been successfully really measured with InSAR. Here you can see we have one-dimensional measurement, but at least they are made for any given area in two different acquisition geometries: descending, so from the right, when the satellite goes from north to south, or ascending, when it goes from the south to the north, and then it watches the same area from the other side. It's important to have these both viewing geometry because we can at least constrain fairly well the vertical and east-west component of the displacement field. And because of this funny geometry, vertical displacement fields, such as caused by a MOGI and a sill, they are all seen as concentric, while dikes, which have also horizontal motions, they have at least 2 or 3 lobes. So the Erta-Ale ridge, which is the focus of this presentation, is actually a very long ridge. It's 150 kilometers and it's just punctuated by several volcanoes. From the north, they are Dalor, Gadale, Borale, etc. And they are extremely active magmatically. And here I'm listing just a few of the mainly dike intrusion and eruption that occurred since InSAR started. And another characteristics of the area is that these volcanoes have extremely shallow magma chamber, and Alu dalla Filla is a 1 kilometer depth, but same Erta-Ale. Well, Erta-Ale, you can clearly even see it, and same Dallo. So they are all with at least one reservoir at very shallow levels. And these eruptions in July and November, they occurred here at the tip, at the Erta-Ale volcano, which also gives the name to the entire ridge. That's quite an interesting volcanic system, as there are 2 calderas called the northern caldera and the southern caldera. And the lava lake, the tourist lava lake, by the way, is here in the northern caldera. But it's not just that. Then about 10 kilometers to the south, by the long axis, we have another volcano, which we didn't know whether it was connected or not to Erta-Ale. We now know it is, and it became recently famous, Haile Gubbi. That's practically just a sheet volcano, and it's a long axis. And then another one to the southwest, same distance, but that's actually the highest point, and it's a stratovolcano, Alebago. And the eruption in July 2025, what you're seeing now is some satellite imagery, in particular thermal imagery from Mirova, that show us the onset of this eruption. What we knew is, together with some, obviously, report from people on the ground. So the eruption started with an explosion in the northern caldera, which is this small speck here. So that would be the northern caldera. And where there was also a report of lots of degassing and ashes. And then the same day, the 15th of July, we also see the thermal anomaly at the southern end of the southern caldera. So immediately the new lava flow was in place. And for the following days, you see the same signal, but then fading past the 21st of July. Here is a zoom of these 2 pits. So you can see what I just told you, that most of the activity really at the surface, you would have seen the gassing and the lava flow. And here finally, in the optical image, you can see our nice, relatively small new lava flow at the southern edge of the southern caldera.
You're now at 10 minutes.
Yes, we don't just have Mirova, we also have interferograms. And using InSAR, we could see that the event was caused by a dike intrusion at the northern caldera, then migrated 36 kilometers along the rift axis in only 25 days. This seismicity was relatively low, and only a 4.2 magnitude earthquake could be located here. So it's relatively seismic. And here you see our 3D model, where we can show interestingly how in the north here and below the northern caldera, a dike-like reservoir shrinked as magma was pushed further south, where you see the red colors. And as we go through the 25 days of eruption, we see that the northern portion squashed, and even portion that previously had been injected by magma, they just contracted again. And then you can clearly see that after the 22nd of July, the dike had hit two sills, one under the northern caldera and a second one at Haile Gubbi, indeed. And these are small sills that inflated, so suggesting that the dike didn't only just create a small lava flow and traveled 36 kilometers, it also fed these two small sills at 1 kilometer's depth only. Here you can see the coherence image. It's just the sort of disturbance of the ground, and it just confirms that, you know, there's a lot of fracturing, the purple that you see corresponding to the area that is progressively intruded. And as you move south, you see fracturing and faulting. It's where the ground practically changes characteristics as there were rockfalls and fracturing. There was also some pre-eruptive observation. Here is observed model and residual from 2018 to 2025. So yes, there was some precursory deformation, a very shallow dike at the Ertale, and a deep 7-kilometer source of a sill that contracted for several years before the eruption started. And here it just shows that these deformations are relatively stable and regular since 2020. And finally, this event was followed then by one last eruption just a few days ago, the 25th of November. And you can see that Haile Gubbi suddenly had this explosive eruption, and you can see it again in the thermal anomaly by Mirova. But you could also see that it wasn't just something going on Haile Gubbi, and indeed, it was most of the deformation again occurred at Ertale, where the same dike-shaped reservoir shrank and probably sending magma towards Haile Gubbi that then exploded, and these signal some deflation there. So to conclude, the July dike traveled 36 kilometers in only 25 days. It was segmented, and also it was clearly fed by a dike-shaped contracting reservoir under Ertale. This is also similar to previous events at the same location in 2008 and 2017. But the difference is that in these times, the dikes that were shrinking was much shorter. This is longer. But nevertheless, it suggests that, well, yes, there can be magma ponding and creating what we call a magma chamber even in subvertical dikes that then can replenish and shrink and feed further dike. Also, we are used to think about dikes, that posing hazard, as they travel very fast and they may give rise to fissure eruptions. But here we see another side of the dike, and that is they can also feed seal if they find them on the way. And that's what exactly we think happened at Haile Gubbi. There was fed by the dike, it was replenished, probably some magma mixing occurred in July 2025, and that triggered then the new eruption in November. It's also clear that Ertale and Haile Gubbi, they are magmatically connected. And finally, we have seen now two dikes intruded in Ertale. They are different from the previous one, so it's a step change. All these dikes were outside the main magmatic segment. They were more than 10 kilometers long. And there's a possibility that the rifting have started in Ertale, and that we might see more of these intrusion in the next months, 2 years. Thanks. Sorry, I went too long.
No, that was great. Thank you so much, Carolina. It was so beautiful to be able to have your results so fast after
Yes.
an eruption. That makes me want to move over to this field of science. If anybody has any questions, just put a hand up or ask in the chat. I might ask another stupid question. In terms of when you were talking about the methodology here, you've got the probing in two directions as the InSAR satellite goes over. So the satellites are all going north-south all the time. Now, this particular structure is kind of oriented north-south, but you're not able to probe it east-west. If this whole thing was on its side, would you be getting degraded images relative to what you're able to get with this?
No, well, actually, yes, the satellite, they orbit the Earth only one way, but then the Earth rotates at the same time. So we always catch the same area in two different geometry, one from the east and one from the west. We can see the same area, I mean, almost always. It depends on the archive, but to be honest, with Sentinel, the European satellites, they guarantee that areas of high strain like Alpha are imaged always with the two geometries.
Okay.
And that allows a fairly good resolution of the east-west and the vertical. Actually, obviously, then the satellite is always quite steeply, the incidence angle is quite steep, so that's the best result. The north-south, unfortunately, it remains the most difficult to resolve, and people have tried some forward look and backward look, some other techniques. It's quite hard. But here I was going to say there's nothing really more moving north-south. The rift extend mainly east-west, and volcanic sources, you see, they always have the most important component in the vertical, so you are favored.
Okay, very cool. I see a hand up from Amiha. Would you like to unmute and ask your question? We can hear you.
Hi. Thank you, Carolina. Can you say something about the rift propagation in the central Afar or in the north Afar in general, based on your findings? Like when the dike propagates from Ertaale to Haligubi or further to the south, and also in the Gulf of Aden, we see northward propagation, northwestward propagation. So can you say something? Does it help us to see the bigger picture of rift propagation in Afar?
Yes, I think that this part of the propagating dike at the Ertaale, I mean, here, I think it won't go much further on than Afrera, because tectonically there's a linkage zone, and the rift that takes a step to the next volcanic system called Tatali, which is a right stepping. So I don't think really you'll go through there. I mean, that's my prediction. Take it as you like. And but there's even in the linkage zone, to be honest, there's also recent lava flows. So it's hard to make prediction. But my feeling is that the segment activated now, that representative of the extension and accumulated at Ertaale, is this 36 kilometers, practically from the caldera all the way to the Afrera Lake.
Okay, thank you.
And quickly, Sarah had a question in the chat. Are there people living near these volcanoes?
Yeah, there's next to the lake, there's a village called Afdera, and they also have seen lots of I haven't been there, but I've seen photos of fractures and collapsed buildings. Not very big fractures, that it didn't quite get to the lake.